Okay, good morning, class. You're welcome to Mamu with Jarvis. This is grade 10 mathematics. And like I said in some of my previous classes, we are trying to experiment on a new concept of instead of having it as maths, we're taking it as different aspects having to do with geometry, algebra, and arithmetic. We've done arithmetic, we've treated algebra. Today we'll be going to look at an aspect of grade 10 work that borders on geometry. Now, by way of added information, I have a YouTube page which I would like you to check out some videos and help yourself from time to time to get clarification on some of the concepts. Some of the things I'll be treating now are things I've covered in some other videos, and some uploaded, not uploaded, but with time you have them there as resource materials to reinforce your learning. But for this morning, we would kickstart our journey in grade 10 mathematics by looking at geometry. Geometry. Now, what is geometry? Geometry simply means the study of shapes. Shapes. Everything about geometry is about shapes. There are different aspects to geometry, which you'll get to learn later. But for today, I would not bore you with those details. We would try to go on a progressive run. Okay, we start by looking at the concept of geometry. Geometry as a branch of mathematics is built on three fundamental ideas. 1, 2, and 3. I call it my PLA model of geometry. PLA model of geometry. Now, the question is, what is P? What is L? What is A? Care to find out? Before I go on, I would like to point at this moment that I have a reference text for my program on YouTube, and it's called Essential Mathematics for grade. In fact, I use Essential Mathematics for all my teachings. It's one book I have found very, very good, and I've recommended it highly. It's one book that every student should have in his or her library. Essential Mathematics for SS1 is what we're using for this course. So if you can make the extra sacrifice of having this book, it will be a worthwhile asset for you. Now, back to our discussion. PLA. What is P? The concept is this. For those of us who have been privileged to encounter me take basic tech in grade 8, you discover that the letter P stands for point, L stands for line, and A stands for angle. So geometry is built on these three ideas. Mention any shape. Think of any shape. Think of any shape at all. It's always built around PLA. Point, line, and what? Angle. Now, the greatest task for you as a student is to try to find out how do these terms connect? Because I just mentioned a point, I just mentioned line, I just mentioned angle. How do these points or these ideas, how do they connect? My experience in teaching mathematics over the years, spanning close to about 7 years of professional teaching and up to about 6 years of unprofessional, or if not more, I have come to learn something. A lot of times, students struggle to understand things because they don't have a strong grasp of the concepts. So more often than not, when I start any topic, I try to go back, irrespective of the class, to hit the concepts. Everything you study starts with an idea. I try to go back to look at that idea. Why is that idea? Why does it stand that way? Now, what is a point? There are lots of books and lots of definitions, but by wealth of experience, I've come to understand that a point simply talks about what? It is the description of location or what? Position. So that's what a point is. If I tell you point to the sky, your hand goes up. point at your eye. Your hand goes to your eye. So it is a description of location or position. Where is that thing being talked about? Where is it? You point to that. So description of location or position is what we call a point. But that's not what, as mathematicians, we will bother ourselves about. We are more concerned with how do we represent that how do we represent that? So how do we represent that mathematically? That's our major concern when it comes to this matter. Now, we usually represent a point by a dot and a capital letter. So if I write a point and a capital letter, this is what we call a point, location. So every time you see a point in mathematics, we're concerned with what? The location of that thing. All right, so that talks about a point. Then, what do we mean by a line? Because it's important to have a strong idea of all of these things. Now, what's a line? A line is the connection between points. So when I connect points, what I have is a line. Several things we need to learn about a line. Things like one, what is a line segment? Or rather, let's go, what are the types of lines we have? Now, we have what is called a straight line, and there's something we call curved lines. Now, there are other descriptions to lines, but I will just stick to straight and curved. Now, what is unique about a straight line? What then is unique about a straight line? We say that a straight line is the shortest distance between any 2 points. So if I have 2 points, and I connect them in the shortest distance measurable, what I have done is that I have created a straight line. To form shapes, more often than not, we are more concerned with a straight line. So let's look at that. If I have this as a line, let's say a straight line. This is point A, this is point B. I move from point A to point B. What I have is a straight line. So we can call this our start point, and we'll call this our end point. Every straight line has a start and an ending. Then we can also call this our origin, and we can call this our terminus. So trying to describe what a straight line is. Sometimes you hear things like what is called line segments. That is, if the length of the line is known, what we have is called a line segment. A line segment. There's also what is called curved lines. A curved line. I made mention of this because this is very important when we are forming shapes. You can have shapes that are circular in nature, and they are formed by trying to look at what is called a curved line. All right, so we could have here as A, maybe B, maybe C. So this is what is called a curved line. All right. So that being said, so we've treated a straight line, a curved line. Another important thing you must learn about lines, you've done this before, is that we have just looked at lines in their separate meaning. Now, we also look at lines in terms of interaction. So let's look at lines in terms of their interaction. Lines in terms of their interaction. Lines can interact. Lines can do what? Interact. So how does that happen? Now, lines in terms of their Interaction. Lines in terms of their interaction. How do lines interact? Now, we have different types of line as a result of this. We have what is called parallel lines. When two or more lines are drawn such that the spaces between them are the same, or the lines can never meet. What you are giving birth to is what is called parallel lines. So these are what they call parallel lines. Notice that notice that the word interaction comes into play because you're not considering one line, you're considering a group of lines, or a set of lines preferably. So when you have sets of lines interacting, we say that the name given to them is a function of what the certain behavior we see in them. Now, if the spaces between the lines are the same, what we get is what is called a parallel line, or rather a set of parallel lines. Parallel lines are usually treated as an interaction between lines. That being said, we also have what is called intersecting lines. Intersecting lines. In the case of intersecting lines, we have lines that cut into themselves. So if this is AB, this is CD, these lines intersect, and it will give rise to something we're going to talk about later, because it is from intersecting lines that the matter of the last letter A come to bear. What was the last letter we talked about? We called it angles. So what essentially are angles? Angles come into play or come into bear as a result of lines intersecting, joining, or meeting. So an angle is formed whenever lines, plural, intersect, meet, or join. I come again. Angles are formed whenever lines meet, intersect, or are joined. So let's look at the three different, or rather the two examples of what I've talked about. It's important you remember this concept because it's going to help you understanding a lot of things we'll be doing in geometry. Now look at this. If I lines intersect, what is formed will be, each of these are what? Angles. Now there was something very important I forgot to talk about when I was talking about line. Maybe I should, is what I mentioned it. Now, a line is represented by either a small letter or two capital letters. So a line is represented by either a small letter or what? Two capital letters. So it's either you're using a small letter or two capital letters to represent the line. That's how we represent a line, either by using two capital letters or a small letter. So if I can say line AB, sometimes called a line segment, or I can simply say line A. I seen that, or in the case of my diagram, line X. I seen that. So you need to know these terms very, very well. Notice that when we talked about angles, we said that an angle is, sorry, we'll talk about points. We said a point is represented by what? A capital letter. You're going to see this come to better understanding when we try to join, when we try to create shapes. Now, a line is either two capital letters or what? A small letter. That's why we said that if you look at this, the distance between A and B is small letter x, so that is the line. Or we can say that the line is AB, origin A, and B is the terminus. Or the line starts from A and ends at B. So when we say the line is AB, it means the line starts at the point A and ends at a point called what? B. So that settles that for line. I just wanted to draw your attention to that. So let's go back to angles now. Now for angles, what we have is somewhat interesting. We said that they can either be formed by intersection, they join or meet. Now, so this is an angle. Let me call it A. This is, let's call this X, Y, Z. Let's call this W. So notice that this is lines meeting or joining. This one will be lines intersecting. So when lines intersect, in intersection, the lines cut into themselves. Look at it. The lines cut into themselves. But in joining, they just meet at the point. So you must take note of the differences here when lines meet and when they do what? They intersect. Okay, are we together? So we're treating angles now. We're treating what? Angles. Now, so let's just, for the purpose of understanding, just pick any. So this is an angle A represented by, let's say, X, Y, Z. So this is an angle. I just take this as an example. X, Y, Z is an angle. Now, what you will notice is that an angle is represented by a small letter or 3 capital letters. 3 capital letters from above, comma, we're going to have A, the angle A, or X, Y, Z. Now there are different ways we can write this. We can put a cap on top, meaning angle X, Y, Z, or you can simply say angle X, Y, Z. I seen that, and these are 2 ways you can represent this angle. You can either say A, you can either say X, Y, Z, or you can also say Y, angle Y. I'm going to explain to you when you can use this one. When we come into shapes, I will explain to you when you can use this. So this angle can be represented as this, 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 or this. Any of them is correct for this. When we come to shapes, I will explain more in details why these ideas are in order. Okay. So types of angles. Types of angles. There are different ways people approach this topic, but I'll just take an approach and stick to it. There are 6 types of angles. Now, please, let me make this very clear at this point. When I talk about types of angles, I am using the criterion, the size of the angle. Please let's take note of that. I'm considering what? The size of the angle. The size of the angle. Size of the angle. So I'm not talking about the interaction of the angles. I'll talk about that, because when we talk about the interaction of the angles, we have about two types of angles in that arrangement. But here I'm considering the size of the angle. Now, I'll just maybe put a label A, B, C, D, E, and F. Don't worry, I'll try to ensure that my diagram sticks within that space. Now, the first type of angle is what we call the acute. Acute angle. The word acute suggests small angle, but in mathematics, in our mathematical description, the acute angle referred to an angle that is less than 90 degrees. So we expect this angle is usually what? Less than 90 degrees. So an angle that's less than 90 degrees is called what? An acute angle. But beyond just being less than 90 degrees, as mathematicians, and especially as people who are studying geometry, we're interested in how does it look like pictorially. We should be able to tell how that angle looks like what? Pictorially. So an acute angle will be in this, will take this form. Now, notice that I've introduced something called theta. I thought somewhere, someone was like, Uncle, what is theta? Theta is a term we use to describe the size of an angle. All right, so theta refers to the description of the angle. It's like when we come to algebra, we understand. Like just how you see, like say A, B, C, D. A, B, C, D refers to letters of the English alphabet. So theta is a letter of the Greek alphabet. So it's something we use to describe angles. Don't let that bother you. Just know that this angle, we're concerned with the size. Any angle that is less than 90 degrees is called what? An acute angle. Now, but the big question students will ask will be, Uncle, you're telling us that an angle is less than 90 degrees. So what does 90 degrees look like? Okay. So the second one now, we'll talk about what? Right angle. So how does a right angle look like? Or what does a right angle look like? So it is two, in fact, when two lines are perpendicular to one another. I didn't say much about that. In some subsequent classes, we'll look at things like that. But when two lines are perpendicular one to another, what you have is an angle that is what? 90 degrees. All right. So this is 90 degrees. So right angle is what? 90 degrees. So it gives you an idea of what an acute angle should look like. It should be less than 90 degrees. And then this is what right angle should be. Is that okay? Okay. So let's copy that. Okay, so we go to the third type. The third type is what we call obtuse. By obtuse, okay, so I did say something very important under 90. This one is exactly 90 degrees. When an angle is exactly 90 degrees, we say it is what? Right angle. Right? Now, what is an obtuse angle? Essentially, an obtuse angle, maybe I should rule this so that let's try to create demarcations so that we don't mix the ideas up. Okay, so what's an obtuse angle? Essentially, it is an angle that is what? Above 180 degrees. So I'm not, but less than what? 180 degrees. Now, acute, we said acute is small. What we notice in an obtuse angle is that it tends to stretch out. So it will be something like this. Here again, another interesting question will come up. Now, students would ask, Uncle, you've just told us that above 90 degrees, but less than 180 degrees. Don't mind me always saying uncle, because over here in Nigeria, that's what we do. We always say uncle, uncle. Everybody, it's not a word to mean auntie or maybe relative. It's to say, to show showing respect to the person who's passing knowledge across to you. So you bear with us when we use some of our local things. Now, obtuse angle is above 90 degrees, but less than 180 degrees. The first question a student may want to ask would be, how do I know that an angle is 180 degrees? Because if I say it is less than 180, it means there's something I have to use as a reference. So that's what will bring me to what is called a straight line. I remember the first time I told the students that a straight line is an angle, there was this horror. Are you sure what you're saying? But interesting enough, a straight line is an angle. So a straight line, this is what we call a straight line, marked at the center. That's a straight line. So what do we know about a straight line? For a straight line, it is what? Exactly 180 degrees. So a straight line is exactly what? 180 degrees. That's why it is called the straight line. Okay? So you get a picture of what an obtuse angle is. It is not this one, and it is not this one. It is in between them. So any angle between 90 and what? 107, that's from 91 to 179 degrees is treated as what? Obtuse. Okay. The next one we're going to treat is the one we call reflex. Reflex angle. Flex, when suggest flex, it means spread out. So reflex is to show out. So for a reflex angle, we know that it's an angle. So it is what? It is above 180 degrees, but what? Less than what? 360 degrees. It is what? Above 180 degrees, but what? Less than what? 360 degrees. That's what we call a reflex angle. So how do we draw it? Now look at it. This is what a reflex angle would look like. This part. Remember, I've shown you what 180 looks like. So if this is 180, and I want the reflex angle to be on top, I would imagine dropping my hands like this. So the angle formed moving in this direction to this direction is what is called a reflex angle. It has to be greater than 180 degrees. All right. So that's that. Notice something very interesting. Okay, let's not talk about that. Let's clear the idea, then I'll now do some relevant deductions. Now, F is what we call angle at a point. This one you really need to pay attention to. If I have a point, do you know that there's an angle? The angle that goes around that point is called angle at a point. And it is what? Exactly 360 degrees. So angle at a point is what? Exactly 360 degrees. It is that angle that forms the circle. So if I stay at a point and I move an angle round, what I'm going to have is a circle. And that's why we say that the angle of a circle, considering it from the center, is what? 360 degrees. So these are the types of angles we have when we consider the size of the angles. I'll pause for us to take a while to digest this, and then I would continue. So we'll now consider angles as a function of interaction. Just as when we talked about lines, we talked about types of lines when we looked at, there's even something I left out, maybe in the course of teaching, I'll go back to look at those areas. We also have angles as a function of interaction. These are just standalone angles. There are 6 types of them. An angle is either acute, it's either right angle, it's either obtuse, it's either a straight line, it's either a reflex angle, or it is what? Angle at a point. So these are the 6 types of angles you have. Now, we can also look at angles as a function of their interaction. I won't tell you how many types they are so that I don't commit myself into what I may not be able to defend. But I will trust that you can go through them and then make your conclusion for yourself. The first type of interaction we have between angles is interaction that gives rise to what we call complement or complementary angles. So number 1, there's something we call complementary angles. So when we talk about complementary angles, we're looking at angles, essentially adjacent angles that sum up to what? 90 degrees. Come again. The word complement in geometry refers to 90. So when things are complementary, it means they lie side by side. And in geometry, when treating angles, complementary angles essentially will sum up to 90 degrees. So let's look at what that would be. So we imagine this, whether 2, whether 3. I'm going to use 3 as a hypothetical case. If I add these 3 angles and they sum up to 90, we say that A, B, C are said to be what? Complementary angles. That is, they do what? They sum up to 90 degrees. Not only are they complementary, they are also adjacent angles. Please take note of this. Angles can be adjacent and not sum up to 90 degrees. But in a setup where they sum up to 90 degrees, we treat them as what? Complementary angles. So angles that are adjacent and sum up to 90 degrees are said to be complementary angles. So angles that sum up, angles that are adjacent and sum up to 90 degrees are said to be what? Complementary. And I'm just giving us a clear description of the diagram there. Let's do this very well. So that is what? 90 degrees. So A plus B plus C will give us 90 degrees. You can have a situation where it's just A plus B only, but this is just another example of that, okay? Now, we've talked about complementary. The next one is what is called supplementary. So when in maths, when we talk about supplementary, especially when it pertains to angles, we mean angles that sum up to 180 degrees. And technically, we are talking about angles on a straight line. So supplementary angles are angles on a straight line. And remember, by our earlier narration of the types of angles, we had said that a supplementary angle is what? 180 degrees. So imagine a situation where that supplementary angle is broken down into angles. Now let's look at this. This is a pictorial view of what we're talking about. Let me call this X, Y, Z. Let me call this W, no problem. So all these angles are what? Supplementary. So it means X plus Y plus Z plus W is equal to 180 degrees. So remember here again, angles that are adjacent. Please take note of that. The angles are essentially adjacent. That is, they lie side by side. They lie side by side. Angles that are adjacent and sum up to 180 degrees are said to be supplementary angles. So angles that sum up to 180 degrees, lying side by side, are said to be what? Supplementary angles. Please take note of this. The key word in these two types we've considered is the matter of adjacent. These angles must lie adjacent to one another. That's one. And their total what? So the angles could be 2, could be 3, could be 4, could be 5. But essentially, once they sum up to 180 degrees, we treat them as what? Supplementary angles. Let's allow that to digest. Okay, the next one is what is called sum of angles at a point. Sometimes you could hear the word conjugate. It's not a very common term used, conjugate angles. Now, the concept of conjugate angles is angles that sum up to 360 degrees. Some textbooks will restrict the narrative to say two angles summing up to 360 degrees. If I made that mistake earlier, it's 360 degrees for conjugate angles. So when two angles sum up to 360 degrees, we say that the angles are what? Conjugate. So if I have this, it means A plus B will be equal to what? 360 degrees. So these angles are said to be what? Conjugate angles. When two angles sum up to, two or more angles sum up to 360 degrees, what you have is what is called conjugate angles. I don't know if you heard this before, but know that a term like that exists. Conjugate angles. Angles that sum up to what? 360 degrees. 360 degrees, the angles are treated as what? Conjugate angles, right? Now, while we continue in that light, we can also go to number 4. And I really want you to really read this. You really need to read this so that you have a strong grasp of the concept. Now, number 4, we treat what is called vertically opposite angles. Now, the concept of vertically opposite angles exists where you have the angles that are intersecting. Take notes. This concept exists when lines actually intersect. This concept exists when lines actually do what? Intersect. So when you have lines that are intersecting, the concept there is what? That of what? Vertically opposite angles. So how does it play out? Now look at it. A, B, C, D. So what do you have? So what angles are vertically opposite angles? Now let's come back to Nigeria. You know, sometimes we have things in Nigeria that can help us explain some of these things. You may be children, but I don't know that you've been privileged to hear what they call face me, I face you. Ask your parents, they'll be very happy to explain to you what they mean by face me, I face you apartments. Now, when we're talking about vertically opposite angles, we imagine angles that are facing themselves directly. If you look at the board, A is facing B and C is what? Facing D. So we say that A Okay, let's take note of that. So vertically opposite angles. Okay, let's take a note there. Vertically opposite angles are equal. Vertically opposite angles are what? Equal. So A is equal to what? B, and C is equal to what? D. We say that they are what? Vert up. Vert up angles. And we have vert. So that's the shorthand form for writing it. And this is actually a build-up for something we are going to do shortly. It's a build-up, or sometimes if you're a movie fan like me, it's an Easter egg for formal geometry. There's something we call formal geometry, and we're already building us gradually to that point. So vertically opposite angles are equal. Remember, we had said, I really need to lock this idea in. I try as much as possible when I introduce concepts to lock in the idea I need you not to forget. Vertically opposite angles exist in the setup where two lines are actually intersecting. Look at it. This concept exists when lines actually intersect. So if I have lines that are actually intersecting, this one up, this angle up, will be seeing this angle down, and this angle on this side will be seeing this angle on this side. So that's what we mean by vertically opposite angles. Okay? We'll be going into something that is peculiar to parallel lines, and I need you to really listen very well. Now, angles. There's something we call a transversal. Transversal. Let's see if I got that spelling right. Transversal. Good. Now, what is a transversal? I'll give you two descriptions of where we can make use of the idea of transversal. Take note, a transversal is a line, a straight line that cuts two other lines. Take note of this. A transversal is a straight line that cuts two other lines, either parallel or non-parallel. So I'm going to draw two things on the board now, and then we'll see how this plays out. Now, if the lines I'm considering are horizontal, well, let's get another marker. This one seems to be out. If the lines on the board, these are parallel lines, and in mathematics, how do I tell that they're parallel lines? I will just indicate with this. So these are parallel lines. If I have a line like this that cuts a pair of parallel lines, this line that does that cutting is called a transversal. That's one iteration of this, or one example of this. There's yet another example now. Let's assume I have lines like this, and I have a line that cuts like this. This is also called a transversal. Now, please don't be fooled by the fact that, but uncle, it's like the lines I'm drawing are horizontal, and then the transversal is always vertical. Well, that may look true for now. I can also turn the parallel lines this way and have my transversal cut horizontally. So it doesn't follow. The transversal can be an oblique line. It doesn't really follow. The most important thing here is that when we have a pair of parallel lines or parallel lines, and you have a line cutting them in an opposite direction, what you have in play is a transversal. So a transversal essentially is a straight line. So for a transversal, one, a straight line, comma, what does it do? It cuts lines. It cuts line. Now, look at something interesting. If it's going to cut lines, it can't cut horizontal. No. I think I don't want to be too grammatical this morning. If I say it cuts lines. It can't cut like this now. It must cut like this. How do you see it? So it has to cut like this. That's why it's a transversal. So a transversal, one, is a straight line, cuts lines. What does it cut lines? Either what? Parallel lines. We cut lines. Let's cut lines. Parallel or non-parallel, such that angles are formed. That's essentially what a transversal is. It will cut lines. To cut lines such that angles are formed. That's what it's doing. So you're going to appreciate what a transversal does when we consider parallel lines. Because if we consider lines that are not parallel, you may not really appreciate much. But if you look at the diagram I have on the board, you discover that I can say this is what A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. See that? You discover that with this setup, we have at least 8 angles formed per set of parallel lines. Per set of parallel lines, per set of lines, we have what? 8 angles being formed. Now, our interest will not be on this one. But just to stretch your thinking a little, we know that this angle will be equal to this angle, vertically opposite, vertically opposite, vertically opposite, vertically opposite. But because of the way the line is drawn, we cannot relate these angles here to these angles here. So we want to have an arrangement where we can relate these angles to these angles. The only way that is made possible is when the lines are what? Parallel. When lines are parallel and the transversal cuts across, the interesting thing that happens is that these angles here cannot be related to these angles. So that's one unique thing that happens when we have a set of parallel lines being cut by the transversal. We cannot relate the angles from one set of the line to another set of the lines. All right. So we'll go into parallel lines now and see what happens. So we'll be considering angles on parallel lines. We've said that, I hope you remember that on parallel lines, there are no angles. So when we talk about angles on parallel lines, essentially we are concerned with what happens when they are being cut by a transversal. So look at this. So A, B, C, D, W, X, Y, Z. Okay, now let's look at this. A, when we're looking at angles on parallel lines cut by transversal, the first type of angles we'll consider are the ones we call vertically opposite angles. Vertically opposite angles. So let's try to name them out. You discover that A is equal to D, comma, or B is equal to C. I'm trying to get out A is equal to D, B is equal to C, W is equal to Z, and X is equal to Y. Is that not? That's the first thing we need to consider. The next thing we look at is what is called adjacent angles on a straight line. You've done some of these things before, just to help you remember before we now treat on the curve. Angles on a straight line. Now this is a straight line, so you have A plus B equal to 180. You have B plus D equal to 180. A plus B, straight line. B plus D straight line, C plus D straight line. You also have A plus C straight line. Are you seeing that? Now come to this part. You're going to have W plus X, X plus Z, Y plus Z, W plus Y. So all these are angles, all those angles are angles on a straight line. So the short name will be vert dot up dot angles. So that's the short form for that, vertically opposite angles. So what's the short form for this? We write angles on a straight line. That is shorthand form for that. Angles on a straight line. So that's for this, and this is for this. Now, the next type of angle we'll consider, we've taken vertically opposite, we've taken an angle on a straight line. The next one is what is called alternate. Alternate angles. Now, alternate angles only apply to parallel lines being cut by a transversal. I come again. Alternate angles are equal only when we are treating parallel lines being cut by a transversal. You really need to be very careful here. So now I want to now start the business. Now I must indicate that these two lines are parallel. Sometimes in books you see the parallel lines at the end. Sometimes you see them here. Now, how do we identify alternates? Now, alternate angles essentially are angles that are within the parallel lines. They are always what? Within. So it is top of bottom of top to what? Top of bottom. Look at it. Across. So this angle here, we alternate with this. I seen that. So let's get another marker so that let's see if I have another marker that can help me create that distinction. All right. Then this angle here, we alternate with this. Are we seeing that? So when we're considering parallel lines, you cannot, for this setup, you can only have two pairs that are alternating themselves. So what it means is that C will be equal to X and what? D will be equal to W. So these are the only angles that are what? Alternating. These are the only angles that are what? Alternating. Please take note of that. They always occur within the parallel lines. Top, bottom top to okay, let's look at it this way. This is right, this is left, right, left, right. So bottom left, or rather bottom right to what? Top left. Bottom left to what? Top right. That's how it works for alternate angles. So take note of that. So that settles that for alternate angles. So the next one we have is what is called corresponding. Corresponding will suggest same side. So the nugget to remember corresponding is what? Same side. Same side. So let's see how that plays out here. Now, corresponding is always on the same side. And it is what? It's the concept of corresponding is a concept of mapping the position. If I'm first on top, I'll be first at the bottom. So look at how corresponding works. This top here, will correspond to this bottom top on the same side. I seen it. This bottom here will correspond to this bottom on this side. So let me change the marker. Let's see if I have another color. I don't know if I have another color of marker. Let's see if I have another that could help show the difference. Okay, let's see if this will help us. Now look at this. The top of this will correspond to the top of this. I think this, the top is relative to the line. This is the top of this line, first line. Maybe I should give them face A, B, C, and D. So the top of this will correspond to the top of this on the same side. I said corresponding suggests same side. And then the bottom of this will correspond to the bottom of this. So in considering corresponding angles now, you're going to have that A is equal to W. You're going to have that C is equal to Y. Just using different markers just to show. Then you're going to have that B will be equal to X. I'm going to have that what? D will be equal to Z or Z. So that's that for corresponding angles. That's for what? Corresponding angles. Are we together? Good. Now, there's one type. Okay, let's allow that to let's allow that to sink. Let's allow that. Now, there's a particular type of angle or angles when it comes to parallel lines that I notice books are not treating. And I'm so happy that this book, Essential Maths, has treated it. There's something we call allied angles or co-interior angles. I don't know, it just disappeared from books. I can't remember in the last 5 years I've heard a math teacher mention it. It's shocking. And it's a type of angle. So there's something we call allied or co-interior angles. Allied or co-interior angles. At some point in time, I even stopped teaching it. I have stopped talking about it. I don't tell students about it because I was wondering, is it that it's now outdated? But I'm surprised that in this Essential Mathematics 2020 edition, it's mentioned there. So it means that it's still an acceptable term or accepted term in mathematics. So what do we mean by allied or co-interior angles? I hope you're seeing that, co-interior. So let's see what that means. The first understanding you must have about allied or co-interior angle is that they are supplementary. That is, they sum up to 180 degrees. Allied or co-interior angles sum up to 180 degrees. Now, understand how the sketch works when it comes to parallel lines. For parallel lines, you're only considering two angles. Let that sink. When we talk about parallel lines, you're only considering what? Two angles per time. So, how does that work? So, I'll need to clean up this and show you how the allied co-interior thing works. Okay, so see how the allied and co-interior angles work. Now, please watch. Look at this. These two angles here are said to be allied or co-interior. So there must be rule number one. For allied or co-interior angles, the angles must exist on the same side. So exist on same side of parallel lines. They must exist on the same side of parallel lines. Now that's why the concept of co-interior, that is, their angles that are inside, they are inside the parallel lines. So in describing this, what you're going to have is this one is one, this another. Then let's see if I can get my blue marker. Then look at this also. That's another pair of what? Allied or co-interior angles. So what you essentially you're going to have will be D plus X equal to 180 degrees. Then what you're going to have here will be C plus W equal to 180 degrees. Now there's something I did not mention when I was talking about this. The short icon for this is alt angles. So alternate angles are the shortcuts for that. When we start solving more problems, I'll give better narrative for that. Now this one is core angles. And for this one is allied angles. So those are the relevant shortcuts for that. Okay. Okay, so that's the much we can take for today. I trust you have gained a lot considering the different aspects to geometry. We started by trying to talk about what a point is, went on to talk about line, talk about the interaction between these lines forming angles. We stretched the concept to parallel lines and whatever. And I would trust that I would trust that you have gained so much from this class. Like I promised you, in my next class, we will go into solving problems. What I try to do is to try to give you the different concepts, and let me assure you that I may not have touched everything. There are certain things I may have left out, maybe by error from my part or by reason of oversight. Don't worry. When we start solving, that's the essence of problems. When we start solving problems, we'll encounter some of these ideas and we'll try to deal with them. So till I meet with you next week, I am trusting you will go back and do the needful. What's the needful? Watch the videos. What are the needful? Get to Mamu with Jarvis, subscribe and enjoy yourself. Thank you and have a blessed morning.